Visit for your dom and then put that away. Okay. Today we're going to talk, one of the many things we're going to talk about are intervals of increasing and decreasing, which basically means where is your graph going up and where is your graph going down. Now what's interesting about that is up and down, that's kind of a y-axis thing, isn't it? If it's going up, that's a y thing. If it's going down, that's a y thing. But you're going to answer the question to me in terms of x coordinates. X is like, well, because x do not repeat in functions, it means you have a unique answer. For instance, you might say, hey, it's going up at 1, and that could be like here or here. But in x coordinate terms, there's only one x equals 1. So, for instance, number 1, intervals for which the function is increasing. Well, it looks like it's going uphill. Can't do that, right? It's going uphill from, it looks like here-ish. Okay, I need to make that bigger. From about here on. Now, you're thinking, hey, that's -4. But remember, you're giving it to me in terms of x. So this would actually be increasing from -1 to infinity. It's going to go up forever after. So the answer to that question, which I really wish I could write on the board, is -1 to infinity. Where is it decreasing? Where does it look like it's going downhill? Remember, you look at these functions left to right. So even though both the arrows are pointing up, you read it like you do a book, left to right. So where does somebody think it's decreasing? Yes, sir. Negative infinity all the way up until you get to -1. Very good. Intervals of constant. Technically speaking, at this exact point where it's neither decreasing nor increasing, it's constant. But I don't really think that's what they're going for. An interval of constant, let me just jump to it. Oh, well, now you've woken up, so thank you. Just a second. Let me see if it's one last try. You know what? I don't feel like it. An interval of constant would be like something like this. That's an interval of constant where it's neither increasing nor decreasing. But for our problem today, you're just going to put none on number 1. Because there's really no flat line spot. What about number 3? Who wants Wed Jan to tell me where it's increasing? Where does it look like it's going uphill, Lazarus? 0 to where? Infinity. Very good. Starting at 0 is already going uphill. What about decreasing? I see people shaking their head no. What does that mean in word terms? There's not one. There is no interval of decreasing, nor is there an interval of constancy for this particular problem. Questions about those two? For this one? Okay. Well, remember, you read the graph left to right. So as the graph enters the screen from the left, is it going uphill or downhill? It's going downhill until it gets here where it stops. That's where we got negative infinity and -1. And as you keep looking at it left to right, it starts going uphill. Yeah, I know the arrows make you think it's going up the whole time. But you have to remember it left to right, like a book. Okay. Same thing. Where's number 5, increasing and decreasing? Amanda. Where's it increasing? It doesn't increase. Where does it decrease? Very good. Why is it negative infinity to infinity? Yeah, it has endpoints, no arrows. Very good. Because it has endpoints and no arrows, that would be -2 to 6. And for intervals of increasing, decreasing, you won't really ever have brackets. It's just parentheses. And constant, is there one? No. Number 7, increasing or decreasing at what interval? Fiona. Number this one. Well, it has an arrow, so negative infinity. Yep, negative infinity to -1, and then what? Constant from -1. There you go. -1 to infinity. Ooh, number 9 looks fun. Who wants to tackle number 9? Flynn, is that your hand? Yes, it is. Flynn. Negative infinity to 0. Go on. Perfect. Good. You got it. Questions? If there's not, I'll just kind of sprint through number 11. Constant from negative infinity to negative 2. Increasing from negative 2. Well, even though this changes, isn't it still increasing? So increasing from negative 2 to 4, and then constant from 4 to infinity. No decreasing. Questions? Click. The numbers, if any, at which f has a relative maximum, and part B says minimum. Well, maximums and minimums are just what they sound like. A maximum is like a hilltop, and a minimum is like a valley. Nice, I couldn't think of the right word. So, for instance, on this one, there would be a relative maximum at x equals negative 2. And if you wanted to give the whole coordinate, that'd be negative. Well, you see how it kind of asks the same question twice? It's like, at which f has relative maximum, what are the relative maxima? Doesn't that kind of seem redundant? At what f means gives the x value, and what are they means give the whole coordinate. If you just want to give the whole coordinate, you would answer both parts of the question. So there's a maximum at negative 2, 4. Where would there be a minimum? Looks darn close to 1, negative 1. Yeah. What about here? Somebody raise your hand and tell me what maxes and mins we have. Feels like can. Try to get somebody who hasn't answered yet. Hold on, I know this. Are you just talking? Ryan. Good question. No. Maximums are only when there's like something on either side of it going up and down, something like that. So infinities are all kind of one-sided. So, now that you've answered that, go. Maxes and mins. Don't give it. What? What'd you say? Couldn't quite hear you. For a what? Max or min? Very good. The maximum is 0, 4. What would my minimums be? Jordan, just finish it up. What would my minimums be? Piece of cake. You got it. Questions? Determine whether each function is even, odd, or neither. What does that mean? Well, I'll show you. Let me go back to this for a second. Is this function symmetrical around the y-axis? Functions that are even are symmetrical around the y-axis. Functions that are symmetrical about the origin, let me see if we have one here. No, we really don't. Functions that are symmetrical around the origin, and I would draw one if my board was working, which it's not. 15. It's almost symmetrical. If it was shifted down a little bit, it would be. But yeah, okay, let's just go and use that. If this had been shifted down a little bit more, it would be symmetrical around the origin. What does that mean? Well, if I could draw, I could show it to you really, really easily. But since I can't, I'm going to use my calculator to show you what an odd function would look like. Okay. All right, so we're just going to graph x cubed. That's a classic x cubed graph. And we are going to zoom in. All right. An odd, let me put this in a little board so I can reach it. An odd function is something where if you put both your index fingers on the origin and you went the exact opposite direction, you would have a counterpart on either side of the function, or you could be going up. Okay? That's what it means to be symmetrical around the origin. Even functions are symmetrical around the y-axis. Odd functions are symmetrical around the origin. Now, that is an odd function. How do you think you could look at the function I plugged in and figure out that it was an odd function? It's an odd number. It's literally that simple. And if I had put an even number in there, guess what? It would be an even function and be symmetrical around the y-axis. Something like that. So to look at a function and tell Now that's how you can look at a graph and figure out if it's even or odd. But looking at a function determining it, just look at the exponents. If they're all even, then it's an even function. If they're all odd, it's an odd function. Or if they're a mix, then it's neither. So, what do you think this one would be? Odd. The exponents are 3 and 1. What about number 19? Very good. You have an even, you have an odd. What about 21? Even. What about 23? You're correct. It is even. Because you have x to the second, x to the fourth, and x to the 0. Essentially. What about 25? Even. And anything with a radical will not be either. Because that's technically x to the 1/2, which is obviously neither even nor odd. So, anything with a radical is neither. Questions on how we got those answers? Well, it's also important you kind of understood what I was talking about a second ago with the way those look on the graph, because the next few you have to look at and say, is that an even or is that an odd function? Eric, what do you think about 29, even or odd? You're exactly correct, it is even. Latifa, what do you think about 31, even or odd? Well, even would be symmetrical around this axis. Odds are going to be symmetrical around the origin, so you're kind of going to go the opposite direction. Therefore, it would be an odd function, yeah. 29 even, 31 odd. Now, if they're mostly symmetrical, but one little thing throws it off, like let's say this is all fine and dandy, but then down here at the very end, for whatever reason, this kind of bubbled out, then it would be a neither. They have to be completely symmetrical. So that would be the case. Questions on those two? Well, good, because now what we're going to do is put all that stuff together in like a 14-part problem. Yay, okay. Here we go. I mean a 12-part problem. Here we go. Part A. Now, I'm sorry that I'm not going to be able to write down the answers to these. I don't know why. That didn't work last block. I don't know what happened to it. But, here we go. The domain of f, just like yesterday, how far left, how far right? Negative infinity to positive infinity. The range, how low does this thing go? The range will be the only thing you ever give me in terms of just y. So you're right. -4 to infinity. X-intercepts. Muy bien. Y-intercepts. Well, I guess that would be one other thing you give me y. Intervals in which f is increasing. Let's do one of these numbers. Yes, sir. 4 to infinity. What about decreasing? Yes, sir. Perfect. 0 to 4. And constant. Well, the usual suspects. They've all already answered it. Sarah, where is this thing constant? Negative infinity to 0. Very good. Where does this thing... Okay, again, this is going to look like the same thing. Technically, this one's the x-coordinate. This one wants the whole coordinate. Somebody just tackle both of those. Where is there a minimum in this picture? Somebody haven't called on me yet. Holly, where's it? You just knew I was going to call on you, didn't you? Very nice. 4, -4. What is f of -3? If somebody new does it volunteer, I'm just going to pick somebody. Yes, ma'am. F of -3 is 4. Perfect. The values of x for which f of x, or y, is -2. Where is y equal to -2? Yes, ma'am. At 2 and what? That would be 2 and... There you go. 6. 2 and 6. And even, odd, or neither? Neither. Very good. And if you think, wow, I got out of it, we have another one. And I'll be calling on you for this one if I didn't get you on the last one. I just saved this. The domain. Katie Beth. Negative infinity to 3. Remember, you look in terms of x. That's the domain. And don't forget, there'd be a bracket on the 3 because it's a whole dot. What would... Who am I going to pick on this time? What would the range be, Kevin? Negative infinity to 4 with a parentheses or bracket? It would be, because 4 is included. Basically, if it's ever a question, put a bracket. The only time you really need a parentheses when there's a whole number involved is if there's an open circle. What are the zeros, which is the same thing as the x-intercepts? What are the zeros of this function? Jalen? Perfect. Negative 3, 3. Those will be called zeros, x-intercepts, or roots. Where is this thing increasing? Bridget Passman? I know you just volunteered a second ago. Yep. That would be this entire interval here. Because remember, even though the arrow's down, left to right. It's kind of like that. To 1, I believe is what it is. But yes, negative infinity to 1, parentheses. What about decreasing? Caitlin Davis? That's right. No wonder I didn't recognize that face. That's not saying I'm only calling people I don't recognize. Jenny Bridget. Jenny, decreasing. Very good. For what? Oh, this is a tricky one. We'll let this one be volunteer basis. Somebody volunteer to explain to us what part G means. I will give you this hint. If they're hard like this and somebody volunteers, there's normally a reward involved. Christopher? That's exactly what it's going to be. Now for part 2, can you answer that question on our graph? Negative 1. Well, your description was right. Your answer was lacking a little. Ryan? Yes, and there's one other spot. Can you tell me what that is? It would be. You two may both, when you get to these problems, you can omit one of them. So a 12-part problem, you can both skip one. Now, what this means, for what values of x is your y less than or equal to 0? Which he's exactly right. It means below the x-axis. So basically all you need is everything below. So that's negative infinity to negative 3. But it also says equals to 0. So you'd have to include the 3. Perfect. Relative maxima. The stall. Where is my maximum? It is. Just give me the whole coordinate. Play it safe. Perfect. Values of x, part I. I'm not going to read that. Who can answer part I? Hey, this is the last slide, so as soon as we get this done, we're done. Part I. Zach. Where is the y value equal to 4? 1. Perfect. X equals 1. And is f of negative 1 positive or negative? Leslie. There you go. F of negative 1 is a positive y value. Any questions over any of those things we've just done? In that case, we're finished. There you go.